Assalamu alaikum. Let me begin by introducing myself and the topic. My name is Naima Khan, and today I am excited to present a comprehensive overview of testing in the paper industry. This session dives deep into the chemistry, testing procedures, and innovations that ensure the quality and sustainability of the paper products. Here is a brief outline of what this presentation will cover. In this presentation, we will explore the chemical foundations of paper, practical lab procedures, and various industry standard testing techniques. Whether for packaging, publishing, or environmental compliance, these tests form the backbone of the quality assurance in the paper industry. Let's begin with the basic chemistry of paper. Paper is primarily composed of cellulose, a natural polymer extracted from the wood pulp. The removal of lignin, which binds fiber together, is essential in pulping. Key chemical principles include hydrogen bonding, which enhances the fiber to fiber strength, additives, which include sizing agents and fillers to adjust properties like water resistance and opacity. pH and conductivity affect the ink interaction and paper aging. Redox and bleaching chemistry involves agents like chlorine dioxide or hydrogen peroxide. Now let's look at the chemical reactions that are involved in the paper production. First of all, we will see the chlorine dioxide bleaching. During bleaching, we will remove color causing compounds from lignin using redox reactions as shown in the reaction. Chlorine dioxide and hydrogen peroxide are commonly used agents. Bleaching enhances brightness but must be controlled to prevent cellulose degradation, which shortens paper lifespan. Acidic conditions can accelerate degradation, so monitoring is essential. Here is a reaction how cellulose breaks down under acidic conditions by reducing paper strength over time and converting into the glucose. Hydrogen peroxide bleaching, it is an other common method, involves the release of nascent oxygen to oxide chromophores, further illustrating the integrate chemical balance that defines paper manufacturing. Mechanical strength is one of the most important qualities of paper. Paper must endure stresses during use. Strength testing simulates these conditions to ensure performance. Three primary tests are burst strength, which measures resistance to rupture; tensile strength determines pulling resistance; tear resistance measures the energy to continue a tear. These tests guide product design and ensure durability. Let's start with the burst strength test. This test uses a Mullen burst tester. The paper is clamped and hydraulic pressure is gradually applied. When the paper bursts, the pressure at the rupture is recorded. Strong fiber bonding increases burst strength and vital for products like bag and cartons. The logic of this test is it measures the rupture resistance and high fiber bonding yields greater burst strength. By closely monitoring these tensile strength tests, researchers can gain invaluable insights into paper's sustainability for applications that require the withstand significant stresses and tensions. This data is essential for developing the high performance materials of the future. Next, we move on to the tensile strength. Using a tensile tester, we secure a strip of paper in clamps, apply force until it breaks. This reveals the alignment and bonding of fibers, critical for packaging applications that require high tensile endurance. This test provides critical information about the paper's fiber alignment and bonding, which are key factors in determining its sustainability. Now we will explore how resistant paper is to tearing. Performed with Almendorf tear tester, a pendulum creates an initial tear. The energy required to extend the tear is measured. This stimulates handling stresses and evaluates fiber cohesion. It stimulates shear bud tearing, reflects internal and fiber cohesion. Let's now consider the visual aspects of the paper. Optical characteristics affects aesthetics and functionality in port tests like brightness and whiteness, which is assessed using a reflectometer, opacity tested with an opacimeter, crucial for preventing tests show through in the printed materials. Here's how we assess brightness and whiteness. A reflectometer measured light reflected at 457 nanometer, which the high reflectance means better bleaching and filler distribution. This ensures vibrant, clean-looking paper ideal for printing and publishing. In this procedure, we use an opacimeter to measure the paper's opacity, which is degree to which light is prevented from passing through the material. As I told earlier, it has wavelength of 457 nanometer. Then examine the paper's reflectance or the amount of light that is reflected off the surface. Observe subtle variations in brightness, tone, the texture to gain insights into the underlying chemistry and manufacturing process. The optical brightness relates to bleaching efficacy and filler distribution. Next, we test how opaque the paper is. Using an opacimeter, we compare reflectance on black and white backgrounds. High opacity ensures readability and prevents ink from showing through. Essential for double-sided printing and book pages. Gain insights into the underlying chemistry and manufacturing process of the paper. It indicates how well print can be seen through the sheet, important for printing papers. Now let's focus on important chemical tests. These tests evaluate composition, sustainability, stability, and environmental safety. The ash content, burning paper at 525 degrees Celsius reveals inorganic filler percentage like calcium carbonate. Here is a reaction in which cellulose is reacted with oxygen to form carbon dioxide, water, and calcium carbonate. pH testing indicates paper acidity or alkalinity influencing longevity. Acidic paper degrades faster, impacting longevity and archival quality. Carbon dioxide evaluation measures biodegradability using microbial breakdown. Incubating a sample with microbial inoculum and quantifying involved carbon dioxide indicates its environmental compatibility and biodegradability. Here is a reaction in which cellulose is reacted with oxygen in the presence of microbial respiration, carbon dioxide and water is produced. Now we will explore how paper interacts with water and ink. This affects how paper handles liquid, crucial for printing and packaging. Cobb test measures water absorption. High Cobb means low sizing efficiency. Ink absorption test ensures proper ink drying and color intensity. Surface smoothness influences tactile feel, and printing clarity. Let's look at why paper testing is important in the real world. Testing impacts several areas, which include quality control, which ensures the standards and consistency, product development, enables innovation for diverse applications, environmental monitoring tracks biodegradability and chemical safety, troubleshooting identifies production issues quickly, customer insurance meets ISO and TAPPI standards, building trust. Looking ahead, here are future directions for improvement. To evolve, the industry must adopt automation and AI for real time quality prediction, green chemistry using enzymes and ozones over harsh bleaches, nano additive testing, exploring nanocellulose for enhanced paper life cycle testing, holistic evaluation of durability and environmental impact. Let me wrap up the presentation. Paper testing is perfect blend of science, engineering and environmental care. It ensures performance, quality and eco-friendliness, guiding the industry toward a smarter, greener future. Thank you all for your attention. Allah Hafiz.